Hi, my name is Chris Berg. I'm head chef of DataKitchen, and I'd like to talk to you a little bit about what DataKitchen does and what is DataOps. So the first thing I'd like to talk about is kind of who we are, and probably the best way to think about it is the story that started the company. And as I do this, I'm not going to read the slides. I assume that you're going to read them. So why did we start the company? So my co-founders and I all worked together at a company that did analytics for the farm industry. And we had every role that you wanted to do with analytics. We had people who did data, we had people who did charts and graphs, we had people who did data science. We even had our own software product that we built. And so the story that I tell is, one day I walked into my boss's office and I worked with the team, and we were going to do a whole new set of analytics that were going to come out in 2 weeks, and we're very proud that it was going to take us 2 weeks. And my boss looked at me and sort of asked me why we couldn't get it done in 2 hours. And I left that office very dejected and went back to my own office and got a call from one of my customers saying, "Oh, the data's wrong. If you guys don't get the data right, we're going to kick you out." And further dejected, walked out of my office again and had one of the bright and bushy engineers say, "There's a great new tool. I want to try this. Can I use this tool?" And so sort of live the life of how you deliver things fast, how you deliver things with high quality, and how you help all your team use the tools they love. And probably when that all happened that day, even though it's kind of a story, my first emotion was to sort of blame my boss, blame my customer, think the employees were kind of were idiots. But that's not really the case. Why can't we, as analytic teams, deliver things fast, deliver things with high quality, and let people use the tools they love? And also do things like reuse what you've created. Because at the end of the day, I think analytic teams and their managers just want to show value, just want to provide insight to the organization. And the way the world is today, people want to, you're only as good as your last analytic deliverable. So from our perspective, it's really all about analytic teams. And so there's different roles on analytic teams. There's people who are data engineers who deal with data. There's people who are data scientists. There's people who are data analysts. But at the end of the day, they all work together to deliver to the analytic customer. And our perspective is a team sport. There's multiple roles and skills that these teams work to do both investigative analytics, kind of things that are one-off, and then turn those into recurrent reports or models. And I think, universally, I think analytic teams are perceived as being kind of slow and inflexible. They have embarrassing production deployments. There's kind of a culture of heroism and a culture of, a person who can do everything. And as a result, if you look at Gartner reports or you get out and talk to people, more than half of all analytic projects fail in some way. Either they're late or they don't meet requirements. And this is actually been constant for dozens of years. It hasn't really improved with big data or data science. In some ways, it's just more people having half their projects fail. And so I think overall, these teams want to do something fast and flexible and robust. So what I'm going to do is kind of talk through this process. So you've got an analytic team that's trying to deliver to an analytic customer. And there's just like a lot of really cool tools out there. And if you look at the icons that I've shown, you've got data engineers using ETL tools, using SQL, writing scripts. You've got data scientists and the sort of holy war between R and Python, and the companies that are SaaS shops or SPSS shops. You've got data analysts that are using tools like Tableau, and are increasingly using other self-service tools like Alteryx to do some data preparation. And then you've got the customer who's actually getting things through Tableau online. So you have this diversity of tools, almost an ecosystem, a tool chain. And as the work goes, sometimes people just love their tools. And some people are really good with Tableau. Some people really love other tools. And there's just lots of new tools in the market, open source, self-service tools. And there's just lots of opinions on what's the best tool and what's the best tool chain to work with. And so if you actually look at all these tools underneath the covers, what do they create? And a lot of them have some configuration of the code. Your chart should look in some way, or your R code. But if you look at it from a software engineering perspective, there's actually code in each one of these tools. So whether you're using a visual tool, an ETL tool, or you're embedding SQL, you're actually writing code in an ETL tool, whether you know it or not. In R, of course, or in things like Jupyter Notebooks, that's code underneath. If you look at what a data scientist is doing, again, that may be Python code underneath. And even surprisingly, things like Tableau, even though you may be configuring the charts and graphs, there's a lot of code that you do in sort of Tableau functions, and you're building if-then-else statements. And the interesting thing is that in order to meet your analytic customer, sometimes the code that you create in tools like Tableau will migrate over time kind of to the back of the stack. And we've seen this lots of times where an analyst wants to try something out and throws it up in one workbook, their boss likes it, and all of a sudden everybody wants to see it. And so the problem with doing it in one workbook is that logic has to be embedded in every workbook. And so the work comes of taking it and pushing it back into the stack. And so actually, instead of saying that, there's two perspectives on this. One is that, well, these people shouldn't be doing that. These analysts should be talking to people on the back end, talking to IT, and they shouldn't be doing self-service. We don't have that perspective. We think that everyone should have the ability to do this work, and they all should have the ability to work together to decide what layer of the stack it works in. So if we look at, again, at this, at DataOps, our perspective is that since it's code, if you talk to a software engineering team, and my founders and I have managed software engineering teams over the years, code has its own meaning. It creates complexity, this combinatorial complexity of all the connections. And so you need to test the code to make sure that works. And over the past 10 or 15 years, the software development community has created something called DevOps and Agile as a way to handle that complexity. And so that's actually, we think, is an important part that should be brought into the analytic world. And finally, what's different than just software development is a lot of analytic teams actually manufacture things. They manufacture charts, they manufacture data sets, they manufacture dashboards and models. And there's lots of materials that sort of come in on one side and outputs that come in on the other. And if you think of it as an assembly line where each one of these tools is kind of changing the shape of the data, adding a value, it needs to be a repeatable process. And if you look at the history, people have managed manufacturing processes in a statistical way, and they use something called statistical process control. There's this guy called Deming, who's actually had a big influence in Japan. And you need to be able to measure quality. You need to think of it as a process with a set of materials and inputs and outputs. And so this picture is kind of our view of the world, that the analytics is really functioning more in analytic teams, that there's a bunch of tools, and that's great, that there's code in these tools, that code sometimes works its way back, and that you should think of it as a process that you can test, make repeatable, and work over time. And so, great, that's a really interesting view of the world. What does that mean? Well, it means that you really should do 7 steps to implement this, and this is our best practice. You can use our software to do it, you can do it yourself. But we think that this is so important that we have another video that talks about what this all means. So the first thing is you should add data tests and logic tests. And you should think of them 2 ways, like as that data moves across the manufacturing line, as you create artifacts on it, you need to test that those are right, that the variance is right. But also you need to test that someone along the way didn't change the logic, didn't change the grouping, the categorizations, the model parameters. And also you should think of your process as a beginning to end, end-to-end process as one thing, and put it into a version control system. Keep it somewhere. Don't keep it in just a bunch of scripts distributed across a bunch of different machines. And because it's in version code, you should be able to branch and merge. That means you should be able to take that process and say, I want my copy of it, and I want to do something with it. And once you have that ability, once you say, oh, I've got the end-to-end process, I've got my copy, you should be able to have your own environment to do the work. You should be able to not have to work on production, and you should be able to create that environment yourself. And so having led software teams, I would never dream of having a group of software developers all work on the production system all at the same time, all making changes. That's a recipe for disaster. And so having multiple environments and being able to take those, branch the code, have people do the work in the environment, run all the tests, add new tests, and then merge it back into production is a key step to being able to do things fast with high quality. We also think you should be able to reuse your code. You should be able to containerize it. Another key thing is parameterize your processing. So if you think of the end-to-end process, you don't want to run all of it at once. Sometimes you want to run just the front end, just the back end. You want to have knobs to control that process. And finally, you should be able to use simple storage to store all your data, to store all the results, to be able to pull them back and to create your own environment. So at the end, we have a product. So if you look at these, the problem space we talked about, how to deliver fast, how to deliver with high quality, how to let people use the tools that you love. There's these 7 steps of data ops that we've talked about. And you can assemble all the pieces, all the half a dozen technologies and make it work yourself. And maybe that's your preference. But we've built a software platform that does that. And because we're a company called DataKitchen, we use food metaphors so that our platform has 4 key features, one of which is called the kitchen, another which is called recipes and tests. It's a thing that encapsulates and containerizes all your processing. We have a thing called ingredients, which allow you to do reuse. And finally, when you run a recipe, you create a thing called orders. And so kitchens are where you work, you run recipes, you reuse ingredients, and you actually create orders. And that's the way that we work in our software. And we'll have other videos to talk about that. So that's it. So why do we exist? We exist to help analytic teams deliver things fast with high quality using the tools that we love. Thanks for your time.